A 400 kilogram car slams its brakes while moving forward. I spelled brakes wrong. I'm sorry. I failed you. But I'll rebuke myself with an angry face. While moving forward with a speed of 10 meters per second and slows to rest over a distance of 10 meters. We assume the engine is no longer applying a force to the car, and we want to determine the force of friction acting on the car. So we have the normal force on the car. We have the weight of the car. And we have a friction force going to the left, slowing it down. So basically, when we look at the forces, we know that the normal force and the weight balance, and we know that it's the friction force that's causing the car to accelerate. So we know that friction is 400 times A. Unfortunately, we don't have A. So to get A, we will use kinematics. V squared is V naught squared plus 2A. X minus X naught is my preferred kinematics equation. 0 squared is 10 squared plus 2 times A times X minus X naught. That's going to be 10 meters. And so when we isolate, we're going to get 100 over 20 is A. And so we're going to end up getting -5 meters per second squared for our acceleration. So to get the force of friction, that's going to be F is MA, which is going to be 400 times -5, which is going to be -2,000 newtons. And then for B, we want the coefficient of friction acting on the car. That's friction is mu times the normal force. So we have -2,000 equals mu. Now to get the normal force, we need to go back to our free body diagram. Normal force balances the weight. So the normal force is going to equal m times g, which is going to be 400 times 10. And we should go with absolute values here, by the way. So we get a normal force of 4,000. So we'll just do absolute values. That's better. So we're going to end up getting 2,000 is mu times 4,000. And this is again for G period only, this part. So we're going to get mu equals 0.5. All right, now number 2. A marble is dropped from a height of 2 meters. How much time does it take to hit the ground? Here we go. We're going to drop this marble from a height of 2 meters. Meow. So let's have x naught as 2 meters. Let's have x as 0. It starts from rest. We don't know the final speed. We know that a is -10 meters per second squared. We don't know the time, so let's go ahead. Since we don't know the time, let's go ahead and use v squared is v naught squared plus 2 times -10 times x minus x naught. That's going to be 0 minus 2. And so we're going to end up getting v squared is 0 squared plus 40. So v ends up being about 6.36 meters per second. Now for b, we want the time it takes to hit the ground. So we could say V equals AT plus V naught. And we'll work in absolute values here. So we'll say that 6.36 equals A times T, which is 10 times T plus 0. T ends up being 0.636 seconds. So for G period, now we have this constant velocity buggy that's here, and we want to know how far away it needs to be to catch the marble. So we have that the buggy has a speed of 0.4 meters per second. So x is v naught, t plus x naught for the buggy in part C, because it's moving at constant speed. So x is going to end up being 0.4 times 0.63, and we'll assume it starts at the position of 0. So when we actually work this math out, I think it ends up being about 0.25 meters. Let's just see. 0.252 meters. So that's it for part C, and that is page 5, I believe, of the exam.